Our today's lesson will tell us about work and power as applied to physics. At the end of this video, students should be able to, firstly, understand what work means in physics, secondly, understand what is power, thirdly, understand how these two quantities are calculated and related to each other. Are you ready? Let us begin our journey. We start by listing a few examples of what we commonly call work. Burning the midnight oil is something we all do when the exams are near. As we know, this is the main road to academic success. Office work is often very tiring. We feel totally exhausted in the evening. You surely know this if your parents work in an office. Working on a construction site demands huge physical effort. We now come to the most important question of our today's lesson. What is work? In physics, work refers to mechanical work. In other words, there needs to be a force producing motion in the direction of the force. On this slide, the person is exerting a huge force to move the crate into the lorry. The person pushes forward, the crate also moves forward. We observe that the crate moves in the direction of the force applied. The person, therefore, does work. Here, work is done as the lady pushes the trolley forward. This is because there is a force producing motion in the direction of the force. In simple terms, she is pushing in the forward direction and the trolley also moves in the forward direction. Our third example refers to a person climbing a mountain. Work is done because the person carries his body upwards against the force of gravity. Climbing a rope or climbing a ladder are similar examples of doing work. Is work being done here? Obviously, the boy is pushing very hard, but the wall does not move. Since there is a force but no motion, work is not done. Here we see a boy pushing a truck by himself. Is work being done? In principle, we do not expect the truck to move, as there is only one boy pushing. Hence, there is a force, but no motion. Therefore, work is not done unless he is strong enough to move the truck. We are now going to learn the formula for calculating work. We can see on the screen that work done is equal to force multiplied by distance. This formula is often written as W is equal to F multiplied by D, where F is the force applied in Newton, D is the distance moved in meter in the direction of the force, and W is work done in joule. As mentioned in the previous slide, the SI unit of work is the joule, denoted by capital letter J. This unit has been named after the famous English scientist James Prescott Joule. He studied the nature of heat and discovered how heat is related to mechanical work. We now move to an exercise. In this exercise, a boy is pushing a crate. The mass of the crate is 50 kg. He exerts a force of 20 Newton and the crate moves 15 meters in the direction of the force. We are required to calculate the work done. The force applied is 20 Newton. The distance moved in the direction of the force is 15 meters. The work done is therefore 20 multiplied by 15, and this equals 300 joules. As we can see, the mass of the crate was not required in this calculation. We only needed force and distance. We now move to exercise 2. The total weight of the barbell is 500 Newton. The weightlifter raises it from the ground to a vertical height 2 meters. Calculate the work she does. Once more, work done is equal to force times distance, which equals 500 times 2, and this is 1000 joules. So far, we have learnt that work has a very precise meaning in physics. Work is done when a force produces motion in the direction of the force. Work is calculated as the product of the force applied and the distance moved in the direction of the force. We now move to the second part of our lesson. We are going to learn about power. This slide allows us to visualize the power of the athlete. This striking slide allows us to understand power instantly. According to Google, the car on the left takes only 3 seconds to accelerate from rest to a speed of 100 kilometers per hour, whereas the car on the right takes 10 seconds to accelerate from rest to a speed of 100 kilometers per hour. Which car is more powerful? Obviously, the one on the left is more powerful. Power tells us how fast or how slow we are working. Hence, power is the speed at which we do work. Power is the rate of doing work. Power is equal to work done divided by time taken. The SI unit of power is the watt, or the joule per second. As stated in the previous slide, the SI unit of power is the watt, denoted by capital letter W. This unit has been named after the famous Scottish inventor and mechanical engineer James Watt. In this exercise, we are going to write down the SI units of the physical quantities involved in this lesson. The SI unit of work done is joule, the SI unit of time is second, and the SI unit of power is watt or joule per second. We now move to exercise 4. A boy of weight 200 Newton climbs a vertical ladder. He climbs 3 meters in 6 seconds. Calculate, firstly, the work done by the boy, secondly, the power developed by the boy. Work done is force multiplied by distance, that is 200 multiplied by 3, and this equals 600 joule. To calculate power, we divide work done by time taken, that is 600 joules divided by 6 seconds, and this equals 100 watt. In exercise 5, the athlete exerts a forward force of 120 Newton over a distance of 100 meters to run the race. Calculate, firstly, the work done by the athlete, secondly, the power developed if the time to run the race is 12 seconds. Work done is force multiplied by distance, that is 120 multiplied by 100, and this equals 12,000 joules. To calculate power, we divide work done by time taken, that is 12,000 joules divided by 12 seconds, and this equals 1,000 watts. Let us check the understanding of our today's video lesson through this cloze test. Take some time to read it carefully and fill in the blanks with the right words. I'm sure you got the answers all correct. Work is said to be done when a force produces motion in the direction of the force. Work is calculated as the product of force and distance travelled in the direction of the force. Power is the rate of doing work. Power is work done divided by time taken. Today we have learnt what is work and how work is calculated in physics. What is power and how power is calculated in physics. We also learnt the formula which connects power, work and time. We hope you enjoyed this video. We thank you for your time and attention. Until next time, it's goodbye from us.